Welcome, everybody, to the American Space Museum. I'm Mark Marquette. We're so glad you're with us to stay curious today. Today's episode, we're going to talk about Spacelab 1, and here are two technical engineers that worked on that mission in 1983. Welcome, Mikey Haddad.
Good to be back, Mark.
Well, you've been one of our aces in the hole to bring us these programs here once a month.
Sir.
And we've got Scott Vangen with us here. Scott, good
Pleasure to meet you, Mark. Nice to be here. Thank
Scott's, these two guys are level 4 engineers, which I thought was like you were level 3 and then you're working to be a level 4. No, level 4 you're going to find out is the shop they worked in, so to speak,
Yes,
in there.
sir. Yep.
But Scott had a big part of this mission. STS-9, John Young was the commander, his last of 6 flights. A very critical mission in the early days of the space shuttle to show that you could do things right. And we're going to hear all about that today. And but we're a little bit excited about losing a little sleep last night, guys.
What a
Scott,
launch.
how was that launch, Scott? Where'd you see it?
Fantastic. I was on center, and I'm a member, as Mikey is too, of the KSC Amateur Radio Club, and we transmit NASA's Public Affairs Office running commentary for the launch operations on a local repeater. It's actually on the top of the VAB. So I was on center at the building where we have our radio operations and retransmitting that. And at T-minus 10, when they picked up the count, stepped outside, and spectacular, unbelievable.
Yeah.
I think that's the brightest, certainly, launch I've ever seen at night.
And you've seen every shuttle launch, apparently.
Yeah,
So.
and I think that was the brightest. It kind of almost burned an image in your eye. Mikey and I were just talking about that.
Your impression, Mikey, of Artemis 1 on the way to the moon, finally.
It's
It's worth waiting for.
Yes, yeah. I mean, I remember I was here during the Saturn V days, and it was a monster. It was nice to see it go. The power of it was just amazing.
Yeah.
When it jumped off that pad and went in orbit.
Nominals,
Yes,
what
sir.
you want to hear.
Sounds like
it
it
was
would, yep.
just amazing that no problems cropped up there. They had a little quick delay that they fixed there. And yeah, it was nice and a good crowd here on the Space Coast.
Mm-hmm.
We've got our German friends here from what's the station?
ZDF.
ZDF. I want to get that right. They're our favorite German public station there. Okay, ZDF. Suzanne's here. We got Rolf on the camera there. Good friends that we made here, and that's what these launches are all about. I've figured out is making friends that you see at repeated launches. It had to be interesting for you repeating the shuttle launches and seeing people.
Yes, sir. Yeah.
Over and over. At
Still,
6 months intervals or something.
yeah, and still good friends today. A lot of those people you work so close to them, they do become some of your best friends on the planet. And still, they are today after 30-some years.
Well, I understand why now, because it was a lot of fun last night, and we wish the Artemis team well. Marty Winkle, my co-producer, cameraman here. Marty, you have seen the mighty Saturn V roar off the launch pad, all of its. But he was out there selling T-shirts for us and did a great job.
Awesome.
What did you think, Marty, of last night's spectacle?
Well, I'll just say it's great for right now because there's a little story behind it, so it'll take too much time.
Okay, well, we can
Now
stay
we're
curious
intrigued.
with that story maybe on Friday, because we're going to, Thursday and Friday, we'll highlight the Artemis mission and the space shuttles of the month of November. There's 16 space shuttles in November you guys worked on, guys. That was a busy holiday month for sure.
Yes, sir.
Scott, you didn't realize that when I told you 16
No, I had not.
shuttles in there. But we're going to enjoy a program about Spacelab 1, the first time that you guys really did a full science mission inside of a laboratory that was in the payload bay. I'm fascinated. They got some beautiful slides. We celebrate the space workers, and you guys certainly are among the unique group that worked in the payload. But Scott, tell us a little bit about where you grew up and how you got involved in the space business.
Oh, well, sure. My pleasure, Mark. I'm from Minnesota, and maybe a little bit of a Midwestern accent still after all these years. And probably not unlike Mikey's story and many of our colleagues, I grew up in the 60s. So probably
Rock and roll.
Rock and roll. A little
Peace,
too
love,
young to
and
remember
Arizona.
Mercury, but certainly Gemini and, of course, Apollo left a real impression on me. And again, not to sound too cliche, but I knew what I wanted to be in my junior high year, if not even grade school. You know, I got into model rockets.
Huh.
I wanted to work for NASA, and better yet, wanted to be an astronaut. Who didn't, right? Or so you thought.
Yeah.
And college years, 1978, graduate electrical engineer in 1982 from the South Dakota School of Mines and Technology in Rapid City, South Dakota. And consistent with what I just told you, I sent out applications to each of the NASA centers and nobody else. And a little side story, please indulge me. Mikey knows this too well. Our school had a reputation at the time of having 100% job placement. And they were and rightly proud of that. But I would only work for NASA. So as all my fellow graduates from the School of Mines got jobs, I was the one last holdout. And the dean of students would call me almost weekly saying, Scott, what's the deal? He says, I'm holding out for NASA. And fortunately, I got offers from several centers. I ended up picking the Kennedy Space Center, which was by far the best choice, and landed in a group with Mikey and the others that we're going to talk about today called Level 4 Payload Engineering. And it started my 37-year career with NASA. And if there's a punchline on this, not only did my dream of working for NASA play out, but my dream of being an astronaut also played out. I was a backup crew member for STS-67, the second flight of the Astro mission.
Oh, really?
And so didn't get to fly, unfortunately. The primary crew remained all too healthy. That's all right.
With Sam Durant?
With Sam Durant, Ron Parise, and the rest of the crew. There was an Astro 3 planned, but unfortunately was canceled. So I would have flown on 3, but you know how these things work.
Yeah, that's you've got to just go with the flow.
C'est la vie.
When
and
it
it's
happens,
all good.
It happens, and I like to say you can make plans, but you can't plan the outcome.
This is true.
Yeah.
So it's all good, and
We're glad to have you on Stay Curious here, Scott. You looked around our museum a little bit. Did you like what you saw?
I'm impressed, very impressed of what you've accumulated and the stories that you're telling here. It's important to capture that. It's our space history.
Well, let's get off with some of this space history. By the way, thank you, Mark Usiak, for our green screen here. Artemis jumping off the pad. I didn't see how quickly it jumped off. Did it go as quick as a shuttle off the pad?
It went pretty
or do you
quick.
think it went quicker than
It
the
went pretty
shuttle went
quick.
off the pad? Because the Saturn V, of course, was known to lumber off there. There we celebrate Artemis with a great piece of artwork by Chris Calley. All right, Chris Calley there. Here, I can do
That's
that
pretty.
like this. I can show it like that. And we wanted to show again the rocket launch from the press site. I think that was a telephoto lens that Mark used. But we wanted to show last night, November 16th, 2022, Artemis is launched off the pad. Well, November 16th, 1974, Mark's big brother Tom took this photograph of the Skylab 4 crew, or the third crew to go to Skylab, being launched off the same launch pad.
Wow, that's
So
pretty.
how cool is that? The
That's
two
really neat.
brothers sharing the same pad, 46 years apart there, or 48 years apart. So there's a couple other shots of Mark's there, of the mighty beast going off the pad there. So what a great time was had by all. And a good shot here. Rusty, I wrote Rusty's name down, didn't bring it over here with me. He took this photograph. A lot of you on the Indian River probably got a similar photograph of the SRB smoke and the moon in the background
Isn't that
there.
something? Yeah, I was heading
This
towards
was
the moon. You see
Heading
it?
towards the moon there. So, and I love this picture, Mark, that you took. There's the silhouettes down there in the bottom of the press corps. That is 3.5 miles away from the launch site there. So beautiful that we got these beautiful images there of the Artemis. And we'll talk more about that Thursday and Friday on Stay Curious, all right? But we want to talk about the Spacelab 1, and I'm going to turn it over to Mikey and Scott here to go back and forth and tell me when you need the next slide there. So Always got cool patches.
Yeah, this one had, basically these are the number of patches with, again, being Spacelab 1. This is STS-9, which was the first Spacelab module mission, which is that pressurized module. This is the first time that ever flew. And so it was a very, very special mission. Canada, Japan, the United States, and 11 European countries were involved in this mission. Over 70 experiments.
How many
70.
years? How many years back had this program started?
Was it in the early 70s?
Yeah,
right?
about the time we were landing on the moon, the late 60s, they were already thinking about the next steps that we wanted to do. And the decision was made, actually, from President Nixon at the time that he wanted more international partnership for the big ticket projects. And I'm really abbreviating the story, but in the early 70s, when they were trading off of, okay, are we going to build a reusable shuttle or alley-oop and build a space station as a follow-up to Skylab, and they realized that NASA alone didn't have the monies to do both. And again, I'm simplifying the story, is NASA said, well, let's focus on the space shuttle and partner with the European Space Agency, which at that time it was called ESRO, the European Space Research Organization, the predecessor of ESA, said, would you build a space laboratory that would be situated in space inside the space shuttle? And they worked through the formalities of that, which wasn't trivial, if you might imagine, because for ESA, it's a huge step in contribution on the order of about $1 billion in early 70s monies. You know, you can run the inflation calculator there.
Yeah.
But back to kind of answering your question, the seeds were sown back when we were doing lunar operations. The approval process and the agreements were all signed in the early 70s. The process, what they call phase A, B, C, D of making these things, occurred in the mid to late 70s. And then the hardware started getting delivered around, well, the start of the 80s to the Cape.
Yeah.
So that's about a 10-year
Glad
period.
I asked. That's staying curious there about it. I didn't know it went that deep that actually the Nixon administration wanted international cooperation in there, because those are some Cold War tenuous times back in those 70s. Well, and look what's come out of this, and you guys are going to tell us about it. So
That's kind of just a graphic there showing Spacelab with the tunnel and then the pallet in the back there with experience. So again, this is the first Spacelab mission. So there's experiments inside that pressurized canister, and then the pallet behind it, U-shaped pallet, had a number of experiments.
and
as
we've
well.
got a model here out of our museum that you tell me when that's appropriate to bring that up.
Sure.
You're good. Yeah.
And
Okay,
I
Marty.
will. So you let me know when. I guess we'll show some
Let's
stuff
go ahead and bring that up. And,
we can
and
bring
while
that-
you're doing that,
we can
if
bring
I
that.
can elaborate on this first mission, back to our
You got it?
partnership.
See if we can get that.
Yeah.
There, yeah.
There we go. Well, Marty, you're going to have to do some camera work there, sir, for us. Let me go there, and you can zoom in on
Hey, but don't you want to come here?
the table here.
Yeah.
You don't want that?
Well, whatever we can look at the model better.
Oh, I'm sorry.
We can raise it up.
Yeah,
Maybe.
yeah, we're gonna. They're gonna talk about the model
there
a
we
little
go.
bit, and I'm gonna
It
go.
looks
off
like you
camera
can
here
tilt
and
it
get
there. There you
something.
go.
There you go. So what we're holding is a mock-up model of the Spacelab 1 configuration, but a little bit of the history back to when NASA signed an agreement with the European Space Agency. It was for ESA to produce all of the Spacelab components, with just a few exceptions. What NASA was bringing to the table, of course, they're going to launch the missions on the space shuttle, which is not a trivial thing. So the agreement was twofold. One is that ESA would deliver a Spacelab module, a set of pallets, a pointing system that was used on other missions, a transfer tunnel for allowing the crew to get from the module to the middeck of the orbiter. And in return, which was, again, a major contribution, about $1 billion, NASA would fly the first Spacelab mission with a European astronaut in a joint science mission. And the agreement that NASA would buy a second set of all of the hardware that I just said, called the follow-on procurement, FOP. So it's kind of like buy one, get one free in a weird way. But so it was a great arrangement. Some people may argue differently, but I think ESA and NASA, it was a win-win situation. It brought ESA into fold with being a deliverable aerospace giant in human spaceflight payload capabilities. And for NASA, it got a science laboratory that, although we're talking about Spacelab 1, I know Mikey and Mark, you've had other talks where Spacelab flew a couple dozen missions with different types of disciplinary sciences. And so what started as a partnership led to this very multi-purpose disciplinary science capability. And Spacelab 1, as Mikey said, featured a long module. It's a pressurized shirt sleeve environment where they went up and down a transfer tunnel to the middeck of the orbiter. And in the case of Spacelab 1, had one pallet. Pallet was the term used for this unpressurized platform and attached to the sides of the orbiter payload bay that you could put science instruments that you wanted exposed to the vacuum of space. So shirt sleeve environment inside the module for the things that the crew can operate there, and an unpressurized pallet for the science disciplinaries that you want exposed to space. And I might add, it was extremely aggressive on the number of science experiments. I know Mikey mentioned, I think, something on the order of 70 different science. 5 different disciplinary sciences had a space science associated with atmospheric sciences, telescopes for astronomy related, had life sciences, had material sciences, had space plasma physics. Shoot, I might even be forgetting one. I think that's it. And Earth observation. So each one of those, one could argue, could be its own dedicated mission, but to have all of those in this one laboratory at the same time, fabulous, on a 9-day mission was fantastic and unique.
And then you had the international element. So this is, we think, is the real first international.
I wonder how many doctor theses has come out of this.
Well, exactly.
And what I like pointing out, Scott and Mikey, is this 40 years ago laid the groundwork for what's being done today on the International Space Station.
Yes, sir.
Absolutely.
This is the bedrock database that global climate change and oceanography changes and stuff like that the data is from these early missions that you were part of. Well, let's put this down and we'll look at some slides of some of those experiments in detail there. Thank you, Marty.
Okay, yeah, kind of what this was. This is, again, it's the hardware. Scotty described the hardware coming in. Well, this is how some of the racks, those racks that went inside that pressurized module. This is a good picture of a single rack, and if you look kind of in the background, is a double rack, which is basically twice the width. And you can see the blue structure. Again, these items, the gray is a flight hardware. The blue is the ground support equipment. It couldn't support its own weight. It was built to be light. So those blue structures, basically, we had to take it, rotate them out of there, stand them up, and then integrate the racks. One of the things I wanted to mention, too, here was there was so many things that this happened. This is the first time for a lot of this stuff. They've been planning up until you start doing it. You don't know if it's going to work. This is the first time all this stuff was happening. And so one of the things, and I'm just going to use this as one example, was when we got these racks stood up in place, then we had to access it and do a bunch of integration in it. Well, there's plans to just do it with ladders and scaffolding. Again, our techs, we were NASA engineering, NASA quality, NASA safety. The only contractors are technicians. Our technicians, and I'll just use this one example. Our one tech, Jay Smith, mechanical, got with my boss, who was Dean Hunter. Again, Dean was an amazing person as well as an amazing boss. He says that this isn't working. We can't get in this place. And so Jay says, well, I got an idea of building this rotating platform that we could use to sit in to be able to get access to this place. So he came in with the idea. Dean approved it, got it built. It was amazing. It worked like a charm. So again, Jay Smith, I think he's out there walking. You'll see a picture of him later on here. Came up with this concept. We actually won a cash award for it because it really helped us. So I just wanted to show, again, this is how some of the hardware arrived. And then the next photograph, what Scotty was describing earlier, European bridge assembly. This is how the bridge assembly came in. Again, the container's off to the left there. And this is us basically taking off, and you see all the people involved. And again, these are crane ups. We've never done this before for this kind of hardware. So there's a lot of things that went into this. And, because of time, we can't describe it, but it was new processes and everything to make this work. And so
the ninth flight of the space shuttle. And this was Columbia, right?
Yes,
Columbia's being adapted to this, the fleet's matriarch. And Yeah, this I guess the pressure was on y'all because this had to work. This was the future of why we built a 60-foot long, 15-foot wide payload bay
Yep.
on there.
What's the
Of
flight?
course, the Air Force spy satellites had something to do with those dimensions too.
No,
I
that's another
understand.
story, right,
That's
Mark?
another story.
Okay, now this is one of the instruments going on the pallet, and again, Jay Smith is the gentleman in the center there with his hands on the instrument. This is the Faust instrument, which was the far ultraviolet telescope that was installed on the top of the pallet. Our engineer is Tony Ornelas, which is kind of down there lower with the kind of the side with the dark hair, and then our quality guy Ed Grabowski on the right there. We had mentioned him in the last one when he was our guy for the ORS mission. Real good quality guy. But I wanted to show this. This is one of the instruments going on, and then the next photograph. Whoops, I think we had one. Do we have one before that? Okay. Anyways, there was.
Yeah, it was like that.
Yeah, there's that one there. Okay, and then that. Okay, yeah. Then basically, this was a team. That was basically when we were doing some of the testing.
The lady's got the manual book there.
Yeah.
That I've seen.
It's that Spacelab one. That's Owen Garriott in the blue shirt, short sleeve shirt, kind of to the left next to the bearded gentleman, which is Robert Toos. And then Byron Lichtenberg was on the far right, the tall gentleman. He was the payload specialist. And then this next picture I wanted to show was when we were doing this assembly, you thought it was under. This is how high we were. If you look at that, the instrument we installed is behind that white sign at the top of the ladder.
Jeez.
So all this work was done at height. So we had to take into account that you're working 20 feet off the ground, as well as putting these multi-million-dollar, one-of-a-kind in the planet instruments on. And so this is the level 4 area of the operations and checkout building. A lot of us work.
This is the level 4 area.
Yeah.
This is where I thought you guys were like I said, striving to be a level 5 type of thing.
Yeah, this is the west end of the operations and checkout
Scott,
building.
what do these memories bring back for you?
Well, this is fun to see. It's a trip down memory lane. And maybe to help our listening audience understand what we mean by level 4, you're right, it's a bit confusing, is back to those...
You got a picture here if we get to that.
Well, yeah, and I'll set the stage, though, is when we agreed to do this with NASA, they said, well, let's think this through. How are we going to integrate all of these individual experiments coming from multiple places around the planet, from different academia, from industry, from governments? It's going to be a challenge. And the original thinking was maybe we can let everybody integrate them in their locales, and then we'll put them together, kind of like a Lego, Tinker Toy assembly. And they ruled that out. No, that's just not going to quite work. And they converged on a plan. Maybe we'll have all of the instruments converge on a place to be integrated, the first level of integration called level 4. So think of it as assembly line, 4, 3, 2, 1, launch. Level 4 is where the instruments come together for the first time and see each other and kind of mate up to the basic Spacelab system. The original concept was, let's do that in Huntsville, Alabama, at the Marshall Space Flight Center. And the plans were in place. In fact, all of the support equipment for level 4 was in fact produced with the intention of that being in Huntsville and engineered there.
Yep.
I might also add, in Bremen, Germany, they were doing the equivalent for future German and European space flights, that they would have a level 4 equivalent, if you will. Well, this proceeded up to a point where, and Mikey and I know this story all too well, and this happened before I arrived, might have been about when Mikey was starting. A decision was made by NASA management between JSC, Marshall, and KSC, with headquarters, of course, tightly in the loop, that this doesn't make efficient sense. If we do this all in Huntsville, we're going to have to pick it up, move it to KSC, and a lot of that same test equipment needs to come with it to continue the integration process. So maybe to the detriment of Huntsville, Alabama, they gave up level 4 operations and it moved to KSC. And that was a big addition for the ops, because now all of the instruments could come right to the launch facility, which really helped our jobs as a mechanical, as electrical, is that level 4 took the instruments, integrated them physically and electrically in testing. Level 3-2 took those and put them more into the Spacelab components. Level 2, final integration configuration. Level 1 puts it in an orbiter, and then off you launch. So that's the kind of the bit of the history. And we threw out the
That's
term
interesting.
Level 4, and it's affectionate for us because that was this hands-on group of civil servant engineers, as Mikey said, with tech support that allowed us to work with the principal investigators, the experiment developers, and their teams. One last thing I want to share, Mark, and I think it's kind of important. The decision was made at the same time when they moved the operations from Huntsville to KSC that let's make it a civil service position and job, because we want our foreign international partners to be dealing directly with NASA and not through contractors. No offense to contractors, but this is now a binational, trinational, however you want to, multinational, that's the word I'm looking for, relationship. They want NASA to be that primary interface. So when Mike or myself dealt with our partners, we were representing NASA with that. And it worked out well. We benefited because as civil servants, we were young engineers right out of college, but we're working with these world-class scientists and their experiment teams, helping them prepare their payloads to be integrated into Spacelab.
Yeah.
Great explanation there, Scott. NASA's always counting backwards. 432. Shuttle flies backwards in orbit. But no, that's great.
Okay,
well, let's look at some more of this level.
This is where we'll
4
pick up Scotty.
activity here.
Scotty could take it from here because this involves in a lot of the ones. Again, my job was easy. I put the hardware together, cabled it up. Then Scotty and the group had to do the electrical work and the testing. So Scotty.
Oh, sure,
it's all
yeah.
his buddy.
And so
Astronaut Owen Garriott.
Owen Garriott there, and yours truly. Back when I had a beard, it's hard to tell. I'm in the picture. I'm just to the right of Owen Garriott.
Okay.
In my bunny suit, you see a little bit of maybe my nose and hair from a beard there. We are wearing bunny suits, except for the crew standing there.
That's Lichtenstein.
Yeah,
right?
it is. And this is in the level 4 integration area at the Kennedy Space Center, and you're looking at the Spacelab racks, but they are not in the Spacelab module yet. That comes in the next level of the assembly line at level 3 I mentioned earlier. So in level 4, we have the racks that Mikey and his mechanical teams put all into place. Us electricals, when they complete their mechanical work, finish in parallel, we're writing procedures for activating, operating, and testing all of these payloads that the last time they were operated, think about it, they were offline probably in the scientist's lab back in Europe somewhere, or domestic if they're a U.S. payload, but they were interfacing with simulators and building to requirements documents. When they come to level 4, they're now interfacing with the real flight hardware for the first time. And so we wrote procedures that all of the commands, all of the data, all of the telemetry, all the switch throws, all of these things were exercised to verify that it was built, as expected. Not surprisingly, not everything worked. And then you would troubleshoot, identify, and resolve the problem. So level 4 was a very critical time for taking these 70-some experiments coming together that knew nothing of each other, and all going to play together a one dance, if you will, and be choreographed to operate well, safely, and not step on each other's toes, and yet each operate as you expect them to be.
Well, we're talking with Scott Vangen here and Mikey Haddad, that are level 4 mechanical engineers, electrical engineer for Scott there. You share that with our co-producer, Marty Winkle, who's electrical engineer on the lunar modules. And did things you were talking about.
I've been promoted to mechanical engineer. Hey, Mikey, that was easy.
Oh, hey! You always should have been a mechanical guy,
Marty, who we
Scotty.
got watching our show today? How are you today? You want me to read them off fair? We got a big list here. A lot of good people watching. Stay curious today. I'll bet a few of your friends are on there.
Oh, I probably can't
Doug
pronounce
Forrest
his
is
name.
on there. Doug Forrest is enjoying his lunch in Los Angeles. Dave Stange, Tom Usiak, You've got Maynette's down there. Hey, Maynette, we're glad that you're watching. She's keeping you straight, Scott.
Yeah,
you wanna kinda read
always
Yeah,
Yeah.
go ahead, read some more of them off there for us.
I'm bad with names, Scotty. You
Oh,
wanna
I
kinda take a cut
don't
at that?
recognize some of these, but no, I wouldn't know where to start because there's so many good names of people.
We got Rachel Bowler and Emily Gibson's watching. Weston Ledoux, Lynn Langford McDaniel, Lynn McDaniel there, okay. And we've Connie McDaniel's one of our volunteers. Maybe they're related.
Okay.
Vice Madlow Co. Neen, all right. Boy, we've got Russia's watching, all right. Slavenlenko Kirilenko.
Oh, that's really good. That's
yeah.
a good cut.
Ronald Flips is watching. Yazvsky Mann. Felipe Matthews. We got Rawinder Singh. Ganora Evelyn. Lee Wilson. Paul Forrester's watching. Gary Gerald. Hey, Gary. And we got Maynette. William Whiting. Good to see you. And thank you, William, for... We watched the launch from his condo here, several of us. Thank you for your hospitality. Robert Laws in Dundee, Scotland.
That's awesome.
And Ben
Wow.
Husett. Ben Husett's watching today. So hope you're enjoying this one-of-a-kind information there. Hey there, Delania. Delania Yancey just stuck her head in there from Huntsville, Alabama. How'd you enjoy the rocket launch, girl? Come here. We're having a big time here. We got room to say to for a
Sure,
pretty
absolutely.
lady on here. Here's our friend Delania Yancey from Huntsville, Alabama. Going to soon be going up to Embry-Riddle.
Yep,
How things going with you, young lady?
going very well.
Well, we had a great show with her a couple months ago about things up there in Huntsville.
Yep.
And you enjoy the launch?
It's beautiful. Totally worth it. It was
Good.
amazing. I love it.
Good. Well, stay in touch and get me some Apollo 17 stuff
All right,
up
will
there
do.
for Huntsville,
All
all
right.
right? Thank you, Delaney. Well, we love our fans here on Stay Curious. It's Marty and I just pinch ourselves at where this program has gone the last couple of years. But that's what it's all about. She's going to go up to learn how to be she wants to be what'd she say she wanted to be? She's very focused on being some sort of a welder. I think she wants to be
okay.
a welder
Okay.
in the space business. And they certainly need good welders, right?
Oh yeah.
Up there in Embry-Riddle, she'll learn that.
That's a trick. That's not easy.
Well, good. All right. Well, we digress there with our fan base there. So let's, Scott, tell us a little more about these pictures we racked up here.
Well,
That looks like Mr. John Young.
the
on
fact that
far
they're
left.
standing on their 2 feet tells you that it's still on the ground, and we're down the assembly line now. We're now in level 3 or level 2 because the module, the end cone, is on there. Those racks on the previous picture that were open-ended now have been slid into the pressurized module of the can, and we're inside that vessel. So all of the individual experiments have been tested now, and now we're fully integrated with the Spacelab systems that were going on, kind of being tested in parallel. And so you see Owen and
Oh, yeah, I
I'm
think
not
that was
and Ulf Merbold, who flew the mission as one of the 2 payload specialists.
Yeah, they would come down because then, of course, this is what they're going to see in space.
Right.
And so when we tested, they wanted to be there because this is what they're going to see when they fly. And so a lot of the crew participated with Scotty and them for all this kind of testing that was going on.
You know, and again, back just the human interest story, Mark, is, so Mikey and I are a year out of college, and we're in a Spacelab
21
module
years
mission,
old, 22 years old, yeah.
and we're working with the crew on a space laboratory that's going to fly in a few months. I mean, back
Just
to,
the
again, the pinching yourself
Yeah,
stuff.
yeah.
I go back to my personal story of what I wanted to do, and I'm thinking, here I am. And again, I'm surprised at their level of responsibility that we were given right out of college. As civil servants, we were GS7s and GS9s, which is the entry point of an engineer with civil servants. And we're in there working on these multi-million-dollar experiments with world-renowned, some noble laureates from
Right.
science community, working with the crew, and we kind of look at each other. It's like, is the gig up? Is this real?
And it's cutting edge stuff. It's the best available on Earth, right? What you
Unbelievable.
said, Nobel laureates and other
Yes.
people working with you.
So yeah, we're doing some testing, and the space geek in me,
Yeah.
I'm still a human,
Got
and
some autographs
after
there.
hours, I took my Spacelab mission experiment description handbook, and the crew that I worked with had them sign that book, and that's very sentimental to me. That was my first,
Well, that's
Spacelab
what we
mission.
love seeing the autographs and the passion.
Mm-hmm.
It was like each mission ended. It was like the ending of your class or something. In
Well,
high
and
school.
some of these
Everybody wanted
become friends for life.
yeah, and some
when-
you never see again.
Well, yeah, you don't know how your
Yeah.
paths will go, but you find out that the space community is relatively small. You keep weaving in and out of missions together and experiences.
Well, we got some interesting computers there. This is the 80s, the early 80s, and the breakthrough.
This is retro stuff here, Mark.
Yeah.
And yes, early 80s computers. And the reason we put a couple of these charts in there is it's the other side of the story that mechanically you have to put all these things together, as Mikey talks, the nuts and the bolts and the cables, and physically getting this flight hardware. But you need computer simulations for the things that you don't have. For instance, we didn't have an orbiter while we were testing this, so we had to simulate an orbiter. We didn't have all of the Spacelab systems in level 4 yet. They come in level 3 and 2. We had to simulate those. So these computers, many of the attributes is to simulate the missing functions. And, again, tape, reel-to-reel tape for logging.
Which I call the first external hard drive.
That's what it was. And
That's it,
and you'd fill that up, and then it's embarrassing how little amount of data that you actually can store in it, but that's what was technology. Well, I want to point out, actually, that on the left there, that gray box that looks indescript. Now I'll go to the next picture. This is what's in, the next picture there, that's what's inside. And the reason I included that picture, those are all hand wire wound circuit boards, but not circuit boards in the conventional sense. Those are individual wires wrapped between integrated circuits. And each of those boards provided a function between interfacing this ground computer. It was called a Perkin-Elmer computer, operating at a whopping 5 megahertz or something. And through those circuit boards of discrete, what's called TTL logic, which is very ancient stuff, would be able to simulate, again, the missing components we didn't have. And that was made by IBM. And what's remarkable is only 2 of those ever got made on the planet for our 2 checkout systems. And the guy who did it, his name's Bob Bach, was brilliant. But troubleshooting that was a nightmare, as you might imagine. And these are 2 of my fellow colleagues, electrical engineers, and we had an issue come up. And you open that up like a big book, and you have all these zillion wires looking at you, and somewhere in there's a problem. But we'd figure it out.
It was amazing work, Scotty. Amazing stuff you guys did.
This is a hard to read
Yikes,
diagram.
yikes.
Yeah, and there'll be a
Now
test
we're
on
really
this
working
later.
here.
Only included to show somewhat of the complexity that in your mind you think, okay, we know you have to test things, but you start thinking about all the things you need to do said testing. And if it's not mechanical fluids things, it's electrical power distribution, it's command and response and telemetry. There's the data logging. Oh, but you also have to have monitoring systems that if things go out of limit, they'll let you know. Like I said, you have to simulate the orbiter. You have to simulate all these complexities. Take a system like this, and the punchline and all that, not only to check out the hardware, you had to provide a spigot for all that stuff up to your experimenters. They're in a separate room with their equipment because you want them to think how they're going to feel when they're operating on orbit and they have their screens and their displays. Here's what they're going to be operating. I pause to say the importance of that. Up to this point, they've had their experiment.
Mm-hmm.
We come along and we take the experiment away from them lovingly.
Yeah.
but they feel weaned away from that. And they're put in this separate room. And it's like, my God, we're not with our baby anymore. Rest assured, here is what you will see. Here is how you will command this during your mission. And they start to get comfortable with that. This complex system simulates, if you will, the payload operations command center that ultimately they'll operate at. And that, for Spacelab 1, was at JSC. So we're preparing them for their future life during the mission at JSC with this equipment.
All of that going on, and you have a deadline. There is a time in
It's
space
ticking.
where you have to meet this stuff. So that has to be frustrating if things aren't, if these scientists in their are catching on quick, right?
Correct. Oh, yeah. The
You're
clock
like,
ticks.
hey, we got lunch in 2 weeks here. You better learn that, how to do that.
Mikey, you want to talk
Yeah,
about
this
the
one was.
ONC?
I want to throw this one in to show the stuff he was just talking about. Okay, the control rooms is basically on the far bottom left. The level 4 area, basically, you see there in the bottom, and then the user rooms were down on the other end of the building, which is hundreds of feet away. And so this stuff was not all. It was spread out all over the operations and checkout building. It was just amazing. They had to make all these wild long runs to be able to, have this hardware work and have it talk together. And so that's why I just want to kind of physically
Marty,
show
I've
how far
privileged
apart
to
this
been
stuff
in that
was.
building one time, but
It's
you guys
huge.
lived in there.
It's just huge.
Marty, that always struck me too, is how to get from one end to the other is like, okay, I'll see you in 5 minutes.
Well, and if I can add, that building has its own amazing history. It was built in the 60s for
Operations
this
and checkup.
operations and checkout building, and it was used initially for.
MSOB.
Pardon me?
It was MSOB.
Yeah.
Yes, you got it.
And
And
spacecraft operations.
used for the
building.
command
Yeah.
module and the lunar module. The rovers were tested in there. After the end of the Apollo program and the start of Shuttle, the SSMEs were in there being tested. Then it became our world for Spacelab and what we call partial payloads. At the end of the Spacelab program, it was then used for Boeing to work on the space station elements. And then when those were completed, it was turned over to Lockheed, and now that's where Orion is
Around
being
spacecrafts.
fabricated. It's a fabrication plant, basically, there. So it reinvents itself. It's a multi-purpose facility that's got a rich history.
I'm going to pick it up from here, Scott. This is
There's some
This one-
consoles like we have in
Yeah.
our shuttle gallery.
Yeah.
Yeah, Marty.
It's also used for the astronauts, for their, what do you call it?
Crew quarters.
Crew quarters.
Yeah, no, good
Good
point,
point,
Marty.
Marty.
Yeah, the crew, when they come for either the training or the simulations we do, but more importantly, they come prior to launch, and that's where they have a few days before they quarantine before the ticket to ride on their flight.
Thank
when
you
you-
for mentioning that, Marty.
Yeah.
The Manned Space Operations Building, as MSOB, became the Operations and Checkout. That's where you see the walkouts of the astronauts to the van.
And it has a new name now, as you
And now
well
it's
know.
named after Neil Armstrong.
Correct. Yeah.
And, it should actually be on the National Registry as a iconic
you would
building.
think. Yeah. Oh, yeah. There's history behind it.
For
So
all the-
this picture that Mikey included was, we're talking about the assembly line, 4, 3, 2, 1. This is level 1. This is launch processing hardware. It's the same hardware that's in the firing room of the LCC for the shuttle. Same as in your museum here, you have some LPS consoles. This was in the ONC building that we could take that Spacelab module, all those experiments, put it in the test stand with this LPS hardware,
What's that next picture?
and if you go to the next one, would verify that our fully integrated Spacelab 1 in this particular case now was ready to go. And if you put it in the orbiter out at the OPF, there should be plug and play. So that's our final
plug
test.
and play.
That's
Plug and play.
I use that term hesitantly, but we wanted to make sure that we've done everything on every interface. And when we come out of this, we call it the site stand, cargo interface test equipment. It's a dry run for level 1 when we actually go put it into the orbiter, that the same procedures we run in this stand will execute in the orbiter. And 99.9% of the time, that was right? The 0.1% was, again, something was missed and lost in translation. And then it's off to the pad for
And
launching.
when it's on the pad, the kind of an X-ray look inside the payload bay.
That's
there.
a cool picture.
It's a really
Mikey.
cool picture.
Yeah.
That shows basically an overlay. What that is a picture of the Spacelab actually taken at the launch pad, and then of course a picture of the orbiter getting rolled out, and then they superimposed those two pictures together. So that was, if you were to take the payload bay doors and open them at that time, that's what you would see inside during rollout. But this always cool picture, so I that in
Yeah,
here.
yeah.
Yeah,
I always
and-
forget what's under the shrouds and under the doors and stuff is
You know,
real
and-
assets.
Yep.
And it's important to also to kind of mention, and maybe it's implied, but not to our listening audience, we can process payloads both horizontally and vertically. And what that means is ultimately, do we put them into the orbiter horizontally at the orbiter processing facility, then go out to the pad, or do we go right out to the pad with them vertical? And on our Spacelab missions, we did them horizontally.
Yes.
Okay.
And there was multiple reasons for that. The reason that's an interesting picture, and we're not talking about Spacelab 1 anymore, but talking about a future Spacelab, maybe you already have or will talk about, where because we integrate horizontally, but go out to the pad and it goes vertical, how do you get into that module if you need to do a late stow of something? That's a separate story, and one that I'm
we
sure
had a
Mikey
great
will
show on
elaborate.
that with
Okay.
with the animals. And
There
the
you go.
monkeys.
You got that.
Yep.
Yeah.
That whole
yeah.
vertical access kit. But this picture really drives home the challenge in being able to do that.
Yeah. What was the? It was
The
the
Spacelab 3. We did a
Okay,
a
you did that.
Spacelab
51J.
F, I think it was 51F. Was it 51F? It was Spacelab 3.
Okay.
Yeah.
And that was basically the MVAC operation to get those animals down in that,
Yeah,
Yeah,
because the
pressurized
animals
module.
couldn't stay days out there on the
No.
pad without food and water.
literally
and all
without
that.
hours of
Yeah,
launch.
that's a fascinating program.
Yep.
You can look up in our archives on YouTube and Facebook there. We're winding down here with a great conversation with these two gentlemen, Scott Vangen and Mikey Haddad. I enjoy these technical talks. They're not too technical that I can't understand them, and hope that you all are following here. Because once again, 40 years ago, and now 20 years of continuous occupation, 22 years on the space station.
Yes.
This is what they're doing, and you guys helped lay the groundwork for this. So there's a launch.
That's
who
a
are these,
great shot.
handsome people?
Well, you know, I
Sure.
should have denial of this picture, but I did give it to Mikey. That believe it or not, that's me on the right
Aha, nice
with
beard.
hair and a beard, and
Yeah.
40 years ago. The woman standing between the three of us there, or in the middle of us, it was Donna Dawson, who ultimately married John David Bartow. And so
Okay,
that's
astronaut
Donna Bartow. And I understand you had John David on
We did.
recently, and that's his wife. She was an original level 4 electrical engineer. She was there when I arrived. And if it hasn't been stated clearly, we were a very young group.
Yeah.
And as Mikey said, nobody had done this before. This is all new. Shuttle was new. Spacelab was new. Payloads was new. Horizontal processing was new. The checkout systems were new. You know, so it's not like you can go ask someone, how did you used to do this?
Right. Yeah.
Now, there was a few graybeards, if you were, who worked Shuttle, or pardon me, Apollo,
Apollo.
that had that heritage of how you do checkout and verification and doing the right things to fly safely. But how you do that for the new program, that's very different. And then the gentleman to Donna's other side from where I'm at is Herman Kerscheid, and he was with ESA, and he was a lead program manager, if I remember right, Mikey. Did I got
Yeah,
that?
I think that was, he was kind of like
With-
the program manager, but I think one of his responsibilities was integration and testing of the Space
With
Lab
ESA,
1 with
yeah.
ESA at the Cape. Yeah.
Yeah, and in fact, he still keeps in touch with us, with Ann Bolton, I think.
Yeah,
I
yeah.
think they're good friends
Yeah,
to this day.
Like I say, that's back in the 80s, and they're still good friends. Here
And
in
that's the
2022.
countdown clock. It just picked up from T-minus 30 there,
There
as
you
you can
go.
see. And then there's better pictures of STS-9, but that's my picture with a little Kodak camera. And so this is November of 83.
Right.
I've been
November
work-
30th, actually.
Yeah, I've been working there a little more than a year, and they're flying something I and
Wow.
Mikey and the rest of us have been working on kind of nonstop. and tell me that isn't just like the
The
coolest
First
thing in the
time,
world.
Exactly.
Yeah.
You got a picture of it.
Well, it's just the
They made it
excitement
to
of that.
space. There's
There they are.
There they are working in orbit there.
Yep.
And it
Now
was quite a mission,
Now
wasn't it? Pretty.
this one I want to tell a little
Okay.
quick story. It's Byron Lichtenberg. It's an experiment called hop and drop. It basically is like when you go to fall, your body reacts to try to stop you from falling. This tests what happens with that in space. What I want to talk about this was you see all the bungee cords.
Right.
One of the bungee cords down on the bottom, about kind of to the right, it was basically a fitting. Well, these panels on the floor, you'd have to pull up every once in a while to get access. Well, the bottom bracket interfered with the panel. You couldn't open the panel. And this is, again, just one example of things that you planned and didn't go right. So it's like, well, what are we going to do? You can't be taking this bracket on and off. And so one of the guys in our group, Frank Valdez, he was in the boating, he says, I got an idea. And I got to read this thing off. He goes, there was this thing called a Schaefer Spinnaker pole slider. Okay. And if you use it, go to the next photograph. Basically what it is, it's something you use on a boat.
Yeah.
Okay. And what you do is this ring slides on and off. That little pin holds it in place. Okay. He says, use one of these, replace that bracket that's permanently mounted there, and put one of these things
I
in.
see the round ring.
The
is
round ring is-
sliding on the
right.
rectangular.
And the bungee
platform.
cord connected to that ring. And so he's used one of these. So he modified the bracket that this thing went to on the bottom of the rack.
Wow.
And it
interesting.
worked. It
Huh.
worked. We were able to then fly this bracket. And if they needed to get in the pen, they just popped that pin, slid the thing off, did their work, and slid it back on, popped it into place. And Byron Lichtenberg was one of the, and I want to say just real quick about Byron. I'm still in touch with Byron today. After all these years, we're still good friends. He was the one that actually started the Zero G Corporation, which is where basically it's a private vomit comet. You know what the vomit comet is? Where you can fly basically on a vomit comet as a private citizen. He developed that. Another thing too, just be real quick. He went to work for Southwest Airlines as a pilot. Well, we used to fly a lot for Space Station and that. I'm on one of the flights and I hear his name come up. Byron he used to work with back in the 80s. But I get the stewardess. This is long before 9/11. And so he goes, I was like, Byron. I saw the stewardess. He goes, yeah, that's the ex-astronaut. Oh, I used to work with him. Can I talk to him? He goes, sure. So I go up, kind of that entrance area where they got through the coffee. So I go up and Byron comes out and we start talking and joking. We just, like we haven't lost any time. Finally, the stewardess comes over. She goes, sir, we need to get this plane off the ground. Can you guys stop talking? We can fly this plane. And so it was just a great story. And then, of course, I sat down and it was just one of the things after all those years, we got together. And like I say, still today, we're in touch with him. He's a very good friend. So I just wanted to bring that up. It was one of the zillion stories that come out of these kind of flights.
The space program is a special bond, no doubt about it. I envy some of the photography bonding, being an Associated Press photographer and missing those camaraderie. One of your colleagues, Brad Byron's watching today.
Hey,
Hi,
Brad. How you doing?
Sharon McDougall, Suit Tech in Houston. Hey, Sharon. Daniel DeYoung, he is a pilot of those Airbuses up there and comes down here. And Daniel, make sure you see me. I got some Ukraine things for you. His wife's from Ukraine. They have a museum there that they wanted some swag for the Ukrainian astronaut that flew on STS-87.
Okay.
I believe in there. So Daniel, good to see you at Zorella's restaurant the other night there where we partook. And Tom Celentano, good to see you, my friend. So a lot of good people watching our program today. We mentioned Maynette Smith, who's been right here in the hot seat like you were today, Scott. Hope you enjoyed your visit on Stay Curious. We certainly enjoyed having you.
If I can, I've got a couple little fun facts about Spacelab 1 that was, I think, significant. First, we've talked about it. It's the first time that ESA teamed up with NASA in the big way with that $1 billion contribution. It was also the first time that we had non-career astronauts fly for NASA. We had payload specialists. That was a new breed that came on board. And then on top of that, we had the first non-American astronaut fly on a U.S. vehicle, and that would be Ulf Merbo.
Right.
And we also had, on that particular mission, it was the longest shuttle mission to date, 9 days. We broke a record.
Probably biggest crew, too.
And it was the largest crew. You had the commander and the pilot. You had 2 mission specialists and 2 payload specialists. A crew of 6. It was the largest. It was the first dual shift, 24-hour continuous operation science mission.
Hmm.
So you had a red crew and blue crew, 3 and 3,
Really?
and
Yeah.
continuous operations, which is a big thing because that had never happened
Right.
in the history of human spaceflight up to that point. And last but not least, or actually 2 more things, it was the first use of something called the POC, Payload Operations Command Center. It was at the Johnson Space Center and was there until up to Astro 1, the first astronomy mission in STS-35, and that moved to the Marshall Space Flight Center. So the first use of think of it as a command center, mission control, but for the scientists. And then the last was good old TDRS. It was the first time that we utilized TDRS and its ability to have near contiguous telemetry and command capability for our science payloads.
Well, that's
'Cause-
important. The Tracking Data Relay Station.
Yes.
You want to explain what TDRS is?
Yeah, the
Yeah.
TDRS Tracking Data and Relay Satellite was a constellation of satellites that were put out at geosynchronous orbit. And what that allowed NASA to do is, as while we were operating these space shuttle missions, up to the point prior to TDRS being deployed, it relied on ground stations. And so you would fly for a while and have coverage from an antenna on the ground, but then go loss of signal, LOS. And during that time, you'd have to record all of your data. And then when you come to the next ground station, quick dump it down before you lose comm again. And as a scientist, you could see that would drive you nuts because you're operating some, multi-million-dollar instrument, and now you see it, now you don't. Now you see it, now you don't. Now you can command it, now you can't. TDRS allowed us to have that nearly contiguous coverage because you have these satellites, like I said, out at geosynchronous, so they're basically fixed with the orbit of the Earth, and it allowed our science community to be able to almost real-time continuously operate their payloads, which was a big deal. So I wanted to share with you that on top of everything else we've talked, I mean, there's some other significant first. It was a big deal for Spacelab 1 to come to bear. And so early in the space shuttle program,
Ninth
on top
mission,
of that.
the 9th mission to fly, and it all
Yeah.
happened on the 9th mission.
And all about a year after we started.
And it was a great mission, right?
Highly
All the
successful,
objectives were
absolutely.
gained, and
Oh yeah.
and like I said, the standards that you all set for the future had to be important.
Well, there's components that flew on this that flew on future flights. Too.
Yes,
Yeah.
yeah, reflights.
Reflights.
All right, including probably your little device there that, with the hook thing on there. Well, we appreciate you guys being here today. You've got a book that you've wrote, a place where people can contact you.
Yeah, this is basically that website that, again, Maynette Smith had created. And again, this is the place where two things, to have this for 2 reasons. One is people who work Spacelab, any component of Spacelab, you can go here and tell your story. Okay, tell us what you did, how you contributed, all the fun facts, the fun things you did too, as well as the serious stuff, the problems. Just basically a place where people can dump their brain. To have it as kind of a place where all this information can be housed. It's in people's brains. You'd really like to keep that somewhere where you can see it. And that's the second aspect of this, is then people can go to this same site and read about those stories those people told. And so we created this as kind of a follow-on to the book, because again, the book, you have this much information and the book contains that much. And so all this other stuff that happened that we couldn't get in the book, this is the kind of a place to take care of that.
Shameless plug.
There's a book right there, Mikey's book there, written with Schuyler, Spacelab Payloads there. Very interesting. Not really a book you got to read from back to front. You want to read the beginning of it. You can pick out things in there. I kind of like find that. And I found your buddy Schuyler. I've got one of his books in my library there.
Very seasoned
But,
professional
David-
author. Yes.
Yeah, very
And a
prolific
Spacelab 1
author
on the
there.
front.
Yeah, that's that Spacelab 1 picture and site. Yep.
Well, guys, we can't thank you enough for taking your time to prepare such a nice program here for our Stay Curious watchers out there. We hope that everybody's out there enjoyed what you heard today, and we hope to have Mikey. I know we'll have you back more. Scott, you're always welcome to come back.
Thank you for
Appreciate
inviting
it
me.
there.
I enjoyed it.
And we enjoyed it there,
Mark,
buddy.
always good to be here. It's a lot of fun.
And we'll have Mikey back with December payloads. Maybe Scott will be involved in it. We're always welcome Scott back in Maynette. And who else do we have on here? We have
Well, with Louis Delgado.
Yeah, Louis
and,
Delgado,
and
yeah.
John Bartow for
Yeah.
Spacelab 2.
yeah.
Yeah.
And so we love it featuring these what's happening in the science and of our wonderful space shuttle era, a 30-year legacy unmatched by any other, I think, event you could say on Earth, because what you guys did has changed science. It has changed the way we live in our world today, and not enough credit is given to our space shuttle program and the fabulous space station that it built, of how it's affected our lives. You guys agree?
Yes, sir.
Concur.
Yep.
Concur in
Absolutely.
there.
Yep.
Well, on behalf of our great museum here, we've had a big day, of course, with guests here. The Artemis launch, we're so happy, was nominal.
That was pretty.
Mark Usiak, thank you for your wonderful pictures there. There's another one there of the from the press site that we love there. So Thursday and Friday coming up here, we're gonna put the button on the Artemis, show some more pretty pictures, and we got a lot of space history that is piled up, including going to Skylab for the last time in 1974. A bunch of astronaut birthdays too going on that we'll want to share with you. So until we meet again, I'm Mark Marquette, thanking these gentlemen for being here, and Marty Martin, and saying I can't wait to see you again to bridge the space between us.